Hello. So we're going to talk about velocity and speed in our one-dimensional kinematics. The reason why we laid this out with velocity first, then speed, is because velocity is dependent on displacement. The last video talked about displacement being first and then distance being second, which was a vector. So this might sound a little backwards because velocity is also a vector. It depends or it's dependent on direction. Okay. This vector is something that has a formula. If we're going to find velocity, our velocity will equal displacement over time. Okay. So let's talk about that with a picture. So we have a box. Okay. This box has a person inside of it. It's their little home. Now, this person inside this box will have a little window. Okay, there's our person. This person exits the house in these dots formation, this dot formation, goes around the house, okay, and enters back in the house. All right, so we'll call this house A. So our question could be, we'll write our question up here. From A to A, the person started at A at 0 meters per second, didn't move, but then started their trail, sprinted around the house, doesn't matter how fast, entered the house again at A and stopped again. What is the average velocity? Okay, well, the velocity, the displacement from A to A, the distance from A to A is 0 because they're right back in the house again. Let's say it took the person 20 seconds. So you have 0 divided by 20. Well, that equals 0. Okay? That equals 0 meters per second. So the average velocity is now 0 because the person is right back in. So although it's a vector, you would almost think, well, we're going to add up all of the traveling time. Well, no. The average velocity, we end up being 0 again because the displacement states that nothing occurred. Okay? Now, let's look at speed. Okay? Speed is scalar. It doesn't care about direction. And the formula for speed is we have our average speed is equivalent to distance over time. Okay, and so maybe I'll displacement over time for velocity and distance over time for speed. Okay, so now we need to get a little more information of this individual. So this individual leaves the house and loops around to about 50% of the house. We'll say 50% of the travel is here. So got out, went around, and we recorded the time to be about 10 seconds it took the person to get here, which makes sense because our original question said it took the individual 20 seconds. Okay? So about right here, it took about 15 seconds when we timed the individual, and back into the house was 20 seconds. Okay, so let's rewrite this. Well, not rewrite it, but let's look at average speed. So we're talking about distance. Okay? We're missing something. We're missing how many meters went around this house. What are each of the what's the geometry here? Okay, we'll say a perfect square. Each perimeter of the house here is 10 meters. So if that's 10 meters, this would be 10 meters. This up here would be 10 meters. And finally, this down here would also be 10 meters. So we have to add up that perimeter, which is 40. 10 plus 10, 10 plus 10 plus 10 plus 10. We have an equivalent of 40 meters that this person traveled. Okay, because we're adding up that distance. Remember, distance, you wanna put them all together. So let's write out number 2 here. Number 2. The person traveled from A to A. What is the average speed? Okay, well, let's write in what we have. We have 40 meters. So we have 40 meters. And it took the person 20 seconds. 40 divided by 20 is 2. 2 meters per second. Okay? We can look at a more simplified term. Let's do just a linear. We'll get our human being back here. Okay? And we'll put the land underneath this human being. And we'll say that this is 0.0. All right? We'll say that this is -1. We'll say that this is +1. Now, I'm going to talk kind of funny here. This person, for question 3, we'll call this point A, point B, and point C. I'll also give a compass: east, south, west, north. Okay. So this will be indicative that indeed there is a direction here. So this person travels. We'll even just write this out: from A to B to C to B, back to C, back to A, and then finally to B. Okay? That's a lot. That's a really big question there. And I want to know, what is the average velocity? Something else that we need to know too is how much time it took this individual. So this individual completed that task in number 3 here, completed that task in 20 seconds. So we're going to say 20 seconds to complete that task. Fine. Let's write out what we know. Velocity is equivalent to the change in displacement over time. So our displacement from A to B to C to B to C to A to B. So we can just look at A and we can look at B. Notice I made this huge list in between just to show you that it doesn't matter. So A to B is 1. And I should write meters. Okay, 1 meter. So that's our change in displacement, 1 meter. It took this individual 20 seconds to achieve that goal. Okay? And I can show you the calculation here. We can take 1 divided by 20. We get 0.05 meters per second. All right? Let's take, kind of scroll down a little bit here. let's do one more on speed. Let's go from point A to point B to C to B back to point A. What is the average speed? So remember, speed, we're adding everything up. Okay? We're adding everything up because speed is equivalent, and I'll scroll down just a hair here, a little more, we can still see it. Speed, if we do average speed, that's equivalent to distance over time. And if we can recall, distance means you need to add everything up. I know that's redundant, but different from displacement. You just see the change from point A to point B. Distance, we have to add it all up. So from A to B, that's 1 meter. I'll write it in right above the arrows. From B to C, that's 2 meters. Because from 1 to -1, that's 2 steps. So 1 to 0 is 1, 0 to -1 is 2. So that's 2 meters. Okay. C to B, that's 2 meters. And B to A, that's 1 meter. So we add this stuff up. 1 plus 2 is 3, plus 2 is 5, plus 1 is 6. So that's 6 meters is the distance traveled. Okay? So we have 6 meters, and let's say that it also took this individual 20 seconds to do so. Okay? 6 meters over 20 seconds. We can do our math. 6 divided by 20, we get a 0.3 meters per second. Interesting. Okay, so we've learned that scalars actually sometimes, even though we are making sure that we are just dealing with these scalars, sometimes add in that distance, which is a vector. And when we do velocity, even though it's a vector, we're dealing with scalars. So mixing these two videos together, the video on scalars, or I'm sorry, on displacement and distance, will help out quite a bit. All right, I hope you have a good day.